Hey guys, Dr. Goodin back with another lecture, this time from chapter 13 from the Essentials of Strength and Conditioning textbook. This chapter is all about measuring parameters of athletic performance. Now in this lecture, we're going to talk about some different performance measures, some tests that you can use with your athletes that essentially give you data about various fitness characteristics. And we'll go through things like 1RM back squat and power cleans and vertical jumps and aerobic tests, etc. In the video after this, we will talk about some of the most often used performance tests and give you some examples of that as well. Dr. Goodin here back with another lecture.
At the bell.
Here we go.
I'm Dr. Jacob Goodin, professor of kinesiology here at Point Loma Nazarene University. And like I said, we are going through chapter 13 of the Essentials textbook. Now, all of this information comes from the NSCA, and this chapter was written by Dr. McGuigan. I think that's how you say his name. Dr. McGuigan, if you're watching, sorry if I butchered your name. I think I've seen you before in conferences. But written by Dr. McGuigan, and this comes from chapter 13. It's called Measuring Parameters of Athletic Performance. Now, in this lecture, we'll be talking about performance parameters and some example tests. Now, the first category we're going to talk about is maximum muscular strength. And I think when most people think about strength testing or testing your athletes in the weight room, this is what they think about. They think about the 1RM back squat or a 1RM bench press. There's actually a lot more to it than that. There are a lot of other tests that we can use to give us better insight into how our athletes are performing, but let's take a look at some of those. So maximum muscular strength, this is also called low speed strength. It's related to the force a muscle or muscle group can exert in one maximal effort. Generally, this is tested via a 1 repetition maximum, but sometimes people will use something like a 3RM or a 5RM. I've even seen 10RM being used so that you can plug it into a calculator and get their estimated 1RM. I actually don't like those methods quite as much. I think a 3RM, a max effort RPE 10 3RM is actually inherently less safe than a 1RM just because it's so hard to gauge the weight that would get an athlete to fail on the 4th rep but not on the 3rd rep. And a lot of trainees may not have that type of a nuance in their weight selection. I think a properly spotted 1RM attempt with a sufficiently well-trained athlete is probably much safer. But let's look at some of the other options. Of course, there are 1RM back squats for lower body strength. You could do a 3RM back squat, like I said. 1RM deadlift. This may be applicable for your athletes or for the people you're training. I would say it's sometimes less applicable than a back squat just because there's so much better transfer of training from that upright squatting position than there is from a more hip dominant deadlift position to most sport. Not all sport, to most sport. But you may choose to use a 1RM deadlift as well or in addition to the back squat. I really like the isometric mid-thigh pull. If you don't know what that is, it's essentially putting force platforms underneath an immovable bar. The athlete gets strapped into the bar. The athlete assumes the mid-thigh pull position, or what's commonly referred to as the power position, like the top of an Olympic weightlifting movement, upright trunk, knee angle of about 135. And you strap them into the bar and they pull as hard as they can on the bar, which generates force through the legs, and that's captured in the force plates. I really like this as a 1RM test as opposed to a dynamic test like a 1RM back squat, but not everybody has force platforms. You can also use an isokinetic dynamometer. It's essentially like a laboratory tool. They're very expensive. Most weight rooms wouldn't have one. It locks your joint in. It's a single joint test, like the knee or the elbow, and you could test, let's say, your elbow extensors, and the device is set at a specific velocity, and it will only move at that velocity. And you push as hard as you can against this device, and it registers how much force you produce at a given velocity. The next set of testing parameters has to do with anaerobic or maximum muscular power. This is what we call high speed strength. So we had low speed strength, now we have high speed strength. This is commonly referred to as power, lower body or upper body power tests. This is related to the ability of the muscle tissue to exert high force while also contracting at a high speed. So now we have high force and high speed. We can also call this maximal anaerobic muscular power or anaerobic power. Some examples here: counter movement vertical jump, static vertical jump. These are different. One uses the stretch shortening cycle, the other does not. Broad jumps, the Margarita Kalaman stair test, and I mean, I'm going to be honest, I've never seen this test used outside of like a kinesiology lab setting where you have your students doing it. I've never seen a team take their athletes through the Margarita-Kellerman stair test, but maybe I'm wrong. Let me know in the comments if you've used that with your athletes to great effect. It just seems like a vertical jump is much more sport specific to the vast majority of athletes, unless your sport is running upstairs as fast as possible. I don't know of that sport, but if it exists, I think I might be kind of good at it. Overhead shot put throw for distance, 1RM power clean. All of these involve some sort of external load or your body weight as a load, and the exertion of high forces at fast velocities. So the key point here is that most maximal muscular strength tests use relatively slow movement speeds because of the high forces involved. You just can't push that load as fast as possible, or I guess as fast as possible is slow for these loads, and therefore they reflect low speed strength. The assessment of high speed muscular strength can involve measuring the 1RM for explosive resistance training exercises or the height of a vertical jump. So really, guys, we just want to use both, okay? A 1RM is not going to tell you everything about an athlete because that's only low speed strength. You also want the high speed strength or the power testing as well, so you get a nice spectrum. And in reality, if you could do something like a load velocity curve where you're getting their unweighted jump, their 20 kilo jump, 40 kilo jump, and a 60 kilo jump, and their 1RM, that's going to give you a lot of data points as far as where on that force velocity curve that athlete needs to spend more time training. Now we also have anaerobic capacity. So capacity is different from power. Power is like an all at once, you use it all up like in a jump. Capacity is how long you can sustain it or how much capacity you have in that energy system. So this is defined as the maximal rate of energy production by the combined phosphagen and anaerobic glycolytic energy systems for moderate duration activities. Examples here, 400-meter sprint, 300-yard shuttle, or the yo-yo test level 2. There's two versions of the yo-yo test. Level 1, which is more aerobic, we'll talk about that in a second, and, and level 2, which is faster. You start off at a faster speed, and so it's more anaerobic. These types of tests are really fatiguing, they're very hard, but they're much shorter than an endurance test because, of course, it's anaerobic in nature, and your anaerobic system does not go very much beyond 2 to 3 minutes. So like a 400-meter sprint, most of your athletes are going to be finishing that somewhere between, I would say, 80 seconds at the high end, maybe 90 seconds, depending on the athlete, depending on their size, and down to the low 50s on the fast end. Next, local muscular endurance. This is very different from an aerobic power test or aerobic capacity test because local muscular endurance is getting at the peripheral endurance of localized musculature, not the global organismal endurance, right? So this is the ability of certain muscles, that's the key here, certain muscles that we're focusing on, or muscle groups to perform repeated contractions against a submaximal resistance. So basically, any type of military physical fitness test, at least the old school ones before they started updating them in the last decade or so, were mostly muscular endurance tests. So max sit-ups or max push-ups for a given time or just until failure. The YMCA bench press test, which gives you a fixed load on the bar for men, it's 80 pounds. For women, it's 35 pounds. And you see how many reps you can get on a metronome. So you have to be timed. It's very standardized. And you just see how many reps until failure. So those are examples of muscular endurance tests. In my experience, there's not a lot of team sport athletes that necessarily need a muscular endurance test to guide their training. It's more so maybe specialty athletes, individual athletes, Olympic athletes, not Olympic level athletes, but Olympic sport athletes. Let's say a canoe kayaker, right? You might want to test the muscular endurance of their biceps or their elbow flexors rather, just because they're paddling. Maybe it's a short course and they just need to have this insane muscular endurance to just continue stroke after stroke at a fairly high but submaximal power output. So next we have aerobic capacity tests. This is testing the maximum rate at which an athlete can produce energy through oxidation of energy resources. Okay, so that slower oxidative energy system. Usually this is expressed as volume of oxygen consumed per kilogram of body weight per minute. So milliliters per kilogram per minute. And this is also called aerobic power. The most common example of this is the VO2 max test. If you're an endurance athlete or you've been around endurance athletes, you probably have heard of the VO2 max. It's the body's ability to utilize oxygen per kilogram of body weight per minute. And so that's the most common. You can do it on a treadmill or on a bike. Also, we have a whole bunch of field tests that we can do that have been validated as correlating very highly, very closely with a VO2 max test. So a 1.5 mile run test, a 1 mile run test, or as I mentioned previously, the yo-yo intermittent recovery test level 1. Now, a lot of coaches, especially maybe slightly more old school coaches, will want to stick with things like the 1.5 mile run test or the 1 mile run test, even if they are coaching team sport athletes who are never running at a steady pace in a constant direction, right? For instance, let me give you the example of a tennis athlete who, they're cutting back and forth. Their sprints last maximum of like 3 to 4 seconds if they have to go across court, but then they're cutting and changing directions. But they do that for a long time, right? A tennis match can last for hours. Testing a tennis athlete with a 1 mile run may not be quite as sport specific because now we're asking them to essentially go through a completely different movement pattern, a different style of locomotion than they're used to in the game. Instead, if we do a yo-yo intermittent recovery test, now they're having to pivot back and forth with increasing intensity, getting little short micro breaks at each end, but it's much more specific to what they'd be doing actually on the court. Same thing with a soccer athlete. The yo-yo test is going to be a lot better for a soccer athlete because they can cleat up, they can get out on the grass or on the turf, something that they're used to playing on, and now they're moving actually how they would in a game instead of just out there like a track athlete. Next, we have agility. Now, agility is defined as the ability to change direction or speed of the whole body in response, and response is key here, to a sport-specific stimulus. So agility testing is generally confined to physical capacity testing, such as change of direction. Change of direction and agility are not synonymous with each other. Or cognitive components, such as anticipation. So if you take change of direction ability and cognitive components, such as anticipation and reaction time, together, those two things create agility. Agility and change of direction are not synonymous. So some examples of change of direction tests include the Pro Agility Test, a T-test, 505 test, and then there are many other sport-specific sport-specific change of direction tests. If you add in some sort of a reactive or cognitive component where the athlete is having to make a decision about which way to go, maybe the kind of like the common scene in like a football movie when they're in training camp and they're running the tires, going through the tires, and the coach has a football and he blows a whistle and puts the football this way or that way, and the athlete has to run that direction. That is a reaction time thing. They're not always timing the athlete, but the athlete has to respond and make a decision based on visual input of the coach pointing this way or that way on which direction to go. If you are actually testing agility, maybe you do a T-test, but the athlete chooses whether to go right or to go left based on a signal, whether it's some sort of LED light that flashes or a coach's direction or a whistle about which direction they're going. Or maybe they have to respond to a whistle, so now there's a reaction time component as well. But when the whole course is just mapped out and they know exactly what they need to do ahead of time, every turn, every pivot, every change of direction that they're going to make, then it's not truly agility, it's just change of direction. So definitely important to keep that in mind. Next, we have the speed domain. This is movement distance per unit of time, typically quantified as the time taken to cover a fixed distance. So, in English and plain terms, that just means how fast can you get from point A to point B? And that can be from a standstill, so there's an acceleration component. That could be from a running start, so maybe we're testing max velocity. That could be with any type of locomotion. If you're a cyclist, well, you're probably not going to go test your 40-meter sprint, but you might test the top speed you can achieve on a bike. So some examples here for our team sport athletes that are common: 10-meter acceleration, 30-meter sprint, 40-yard dash, 40-meter sprint. I don't know the difference between when they say dash or sprint. Dash sounds like kind of classical and kind of cool, but I think it means the same thing as sprint. Or a 100-meter sprint. Next, we have flexibility. Now, flexibility is defined as a range of motion about a body joint, A couple examples: sit and reach test, which it's kind of antiquated, but it's still used in a lot of doctor's offices and during physicals. So not necessarily a bad thing, but do I make time for it with my athletes or with my students? No. I'll assess their flexibility in other ways. The overhead squat, though, this is much more applicable, especially for a strength coach. If you're familiar with the functional movement screen system, which I know a lot of you are, the overhead squat is kind of like one of the pillars of that movement assessment. And honestly, it's the only one that I use. I've used the whole FMS before, but the overhead squat, if you have a good eye for it and you view the athlete from multiple angles, the overhead squat really reveals a lot of mobility and stability weaknesses in an athlete. Whether it's dynamic trunk control, whether it's hip mobility, whether it's ankle mobility, whether it's some sort of asymmetry between their shoulder stability or their shoulder mobility. There's a lot that plays into that, whether it's a strength deficit. So assessing overhead squat can be a great functional flexibility assessment. I don't think I would call it flexibility, though. I would call it mobility, maybe even functional mobility. I know the word functional has been really bastardized, but still, I think it applies here, functional mobility. Next, we have balance and stability. Balance is the ability to maintain static and dynamic equilibrium. So it's not just this static, like stand still on one leg type of a thing, but dynamic balance is important as well. What happens when we inject movement into the task? Can you still hold your balance with some sort of a dynamic component? And then stability is the ability to return to a desired position following a disturbance to the system. So what happens after the athlete jumps as high as they can and then they land? How quickly can they return to standing or return to an athletic stance? Or after they're sprinting, how quickly can they get back there? Or on some sort of a Y balance test, can they return back to the starting position? Some examples here are the STAR excursion balance test and the balance error scoring system. Okay, next we have two of what are they're more descriptive tests or testing areas. They're not exactly performance oriented. However, they do play a big role in athletic performance. The first is body composition, and this would be the relative proportions by weight of fat and lean tissue. So common examples of this are the 3-site skinfold test or the 7-site skinfold test. Also, now we have a lot of bioelectrical impedance devices, whether it's the handheld thing or like the in-body one where you stand on it and you have the little handles that can very, very accurately assess your lean mass and your fat mass ratios. You could get a DEXA scan, you can use a bod pod. There's a lot of ways to do it. For anthropometry, this is the science of measurement applied to the human body. It generally includes measurements of height, weight, and selected body girths. Now, anthropometry is great. It doesn't really change like from year to year in your athletes if they're fully mature. However, if you are doing any type of talent scouting, or maybe you want to figure out which role on the team your athlete is best suited for, there might be some anthropometric standards that you want your athletes to hit if they are going to fulfill certain positions. Also, you can, to some degree of accuracy, possibly project future growth or project an athlete's ability to carry more or less muscle mass. So an example of this is a complete ISAC profile. ISAC stands for the International Society for the Advancement of Kin Anthropometry. And what that is it's essentially a group of people who are trained and in this highly specific way of measuring not only skin fold sites for body fat percentage, but also segment girths and bone breadths and limb lengths and about 100 other parameters to get a full profile on an athlete. And then you can figure out things like, what is their body type? Are they, right now, are they ectomorph, mesomorph, or endomorph, or like what ratio of those? And we know those things are not fixed. You probably have genetic predispositions, but with training and diet, you can change those. However, some things are genetically determined, like the thickness of your bones and the breadth of certain, of your shoulders and the lengths of your limbs, those types of things. And we can start to profile athletes that way. I used to be level 2 ISAC certified, And it's a very, very rigorous certification process and can be valuable, especially if you're running some sort of a long-term athletic development program where you're seeing a lot of developing athletes and then trying to figure out the best way to guide their careers as you're going forward. So those are some examples of various performance and fitness tests that we can do to serve our athletes within each of these different performance domains relative to the sport that the athlete is working in. The next thing that we're going to want to talk about is specific testing protocols. So the next video is going to cover essentially sequencing these various tests. Like if you have a testing day coming up, how should you order those tests? What are some environmental conditions that you need to watch out for? And then I'll go over some of the protocols for selected tests. I'm not gonna go through all of them that are shown in the textbook. You can, of course, read the textbook for those, but I will go over some, especially ones that I have more experience with, to give you guys a feel of what that actually looks like practically. So click on over to that video to continue learning. As always, let me know if you guys have questions or other topics you want me to cover. I'll see you guys on the next video. International Society of Anthropometry and, International Society of something kinanthropometry. I kind of forget, you can look it up.